You have already learned the concepts of limits, right? Now, if I ask you a question, what will be the limit x tends to 0 sin x by x? What will be limit x tends to 0 tan x by x? If we substitute the value of 0 in this equation, we get the form 0 by 0. And we know 0 by 0 is not equal to 0, which is called indeterminate form. So we cannot proceed further. So there should be some technique to be applied when such situations arises. And here in this particular video, we are going to learn how to deal with the limits involving trigonometric functions. Right? Now, we have to learn about some facts related to the trigonometric function limits, and these are stated in forms of theorems. Mainly two theorems are there. The theorem number 1. First we will discuss theorem number 1. It states that suppose if you have two functions f of x and g of x which lies in the same domain where f of x is less than or equal to g of x, f of x less than or equal to g of x, then if I apply the limit to this where we consider some point in the domain, let's say x tends to a. So the limit x tends to a, f of x will always be less than or equal to limit x tends to a g of x. If we consider the graph, let this be your f of x and let this be your g of x, where f of x less than or equal to g of x. And if I consider another point a in the domain, then as per the theorem, it states that limit x tends to a, f of x will always be less than or equal to limit x tends to a, g of x. Now let's see the next theorem. Theorem number 2, which is otherwise called sandwich theorem. The theorem states that you have three functions. If I say f of x, another function g of x, and another function h of x, provided f of x less than or equal to g of x less than or equal to h of x. Now if I take some point in the domain, say the point a, then if I apply in the limit, then limit x tends to a, f of x is equal to L, which is equal to limit x tends to a, h of x. If this condition is satisfied, then we can write limit x tends to a, g of x will always be equal to L, where L is called the limit of the function. That means we have to find or we have to evaluate the limit of the function in the middle, that is g of x. And we know what is f of x and what is h of x, which is equal to a value called L. So if this is satisfied, then limit x tends to a, the middle function, that is g of x, will be equal to L. That is the limit of the function. And this theorem is very important and we have to use in our further discussion. Alright. Now we are going to derive a very important property, that is limit x tends to 0 sin x by x is equal to 1, and another property, that is limit x tends to 0 1 minus cos x by x is equal to 0. First we will prove limit x tends to 0 sin x by x is equal to 1. So we'll start the proof by considering a unit circle with center at O and radius OA, and this point is C. Now if I extend this point I can draw a perpendicular to A, and this is BAB, and join C to OA, and you get another point D. Also join A and C. Alright. So from this graph we can write area of triangle OAC is less than the area of a sector OAC less than the area of a triangle OAB. Now what is the area of triangle OAC? It is half into base into height. So half into, what is the base? OA into height is ZD, which is less than area of a sector OAC is x by 2 pi into pi into r square, that is OA square, less than area of triangle OAB. In triangle OAB, the base is OA into height is AB, right? Now we can cancel OA by 2, right? And what is left? CD less than x into OA less than AB. Now mark it as equation number 1. Now we have to find what is CD and what is AB and substitute in this equation. So to find CD, we have to consider the triangle OCD. We consider triangle OCD, and you know this is x. So what is sin x? Sin x is equal to perpendicular by hypotenuse. So CD by, what is the hypotenuse? OC. And we know OC is equal to OA. Therefore we can write it as CD by OA. Right? Therefore CD will be equal to OA into sin x. So we got CD. Now we have to find AB. So to find AB, we have to consider the triangle OAB. And what is tan x? Tan x is equal to perpendicular by base. So what is the perpendicular? AB by base is OA. So what is AB? AB is equal to OA into tan x. Right? Now we got AB also. Now substitute in this equation. Now this is our equation and we are substituting the value. CD is OA into sin x less than x into OA less than, what is AB? OA into tan x. So dividing by OA all throughout, we get sin x less than x less than tan x. Now dividing by sin x, we get 1 less than x by sin x less than tan x is sin x by cos x. Dividing by sin x, we get 1 by cos x. Now taking the reciprocal all throughout, we get cos x less than sin x by x less than 1. And we know, as per the sandwich theorem, the middle term is sin x by x and it lies between cos x and the constant function 1. So if I apply the limit x tends to 0, cos x, what will be the value? It is 1. And the constant function is also having value 1. Therefore, limit x tends to 0, sin x by x will also be equal to 1 as per the sandwich theorem, because it is the middle term lying between the cos x and the constant function 1. Alright, from the equality we proved that limit x tends to 0, sin x by x is equal to 1, and it is a very important property. Right, now we have to prove the second property, that is limit x tends to 0, 1 minus cos x by x is equal to 0. So to prove that, if you look at the numerator, we have to use the identity 1 minus cos x is equal to 2 sin square x by 2. So applying in the equation 2 sine square x by 2 by x. Now again rearranging sine square x by 2, I can write it as sine x by 2 into sine x by 2, and bringing this 2 down, I get it as x by 2, right? Now applying the limit for each term, we get limit x tends to 0 sine x by 2 by x by 2 into limit x tends to 0 sine x by 2. And what is this function? Limit x tends to 0 sine x by 2 by x by 2. It is 1. We have just derived now using the property. Now applying the limit to the second term, that is limit x tends to 0 sine x by 2. Applying x is equal to 0, we get sine 0, which is 0. So 1 into 0, we get it as 0. So the limit x tends to 0, 1 minus cos x by x is equal to 0. Right? Now let's see another question. Limit x tends to 0 tan x by x. Can you evaluate the value for this? So first we can express tan x as sin x by cos x into x. Now splitting it, limit x tends to 0 sin x by x into limit x tends to 0 1 by cos x. Now what is limit x tends to 0 sin x by x? Limit x tends to 0 sin x by x is 1. The value is 1 into limit x tends to 0 1 by cos x. Cos 0 is 1. We know cos 0 is equal to 1. So 1 by 1, the value is 1. Therefore the answer will be 1. Therefore limit x tends to 0 tan x by x is also equal to 1. Now from all these example which we have derived and the property which we have derived, we come to some conclusion or certain things to be noted in mind when dealing with such problems. If you have f of x by g of x, and the question is from limit x tends to a, what you have to do is first evaluate f of a and g of a. And if both f of a and g of a is equal to 0, it will become 0 by 0 form, that is an indeterminate form, and you cannot proceed further. So at that time what we have to do is split f of x in terms of f1 of x and f2 of x. Similarly, split g of x in terms of g1 of x and g2 of x. Now see any common factor in the numerator and denominator, and if there is any common term you can cancel it and you will get this value as p of a by q of a. Substituting the limit and you reach at some finite value. So with that we have completed the concepts related to the limits involving trigonometric functions, and in the upcoming section you will be dealing with the derivatives. Now let's have a quick recap of what we have discussed.
Manorama Horizon, learning made simple.